So this is the lesson for 9.7 for honors geometry, and today we are going to start with a quick warm-up, and then we'll move to something called inscribed angles. So before we get to the inscribed angles, here's a quick warm-up, kind of using some of the proper theorems that we saw on Friday, which were, there was 4 of them, theorems 10.3 to 10.6. And so we can kind of walk through how we would use each of those. I'm not going to write down which theorem exactly, but you can use that. And some of this does use some of your previous knowledge of special right triangles or trig that you can apply to, or Pythagorean theorem. It makes it easier to kind of find those. We did do a couple of these on Friday too with the practice that you can check the video for if you want more questions like this. So the first one, it does say to leave everything in simplified radical form, K is the center, and BD is congruent to HF. So those two chords are congruent. So it says if measure of angle 2 is 45 degrees, and KG is referring to this radius here, is 8. That means all the radii in this picture will be 8 for this first question. So that means KF would also be 8. So I would draw a diagram of that triangle that I'm working with, where 45 degrees is the angle given, 8 is that hypotenuse, because that's the radius, and we are asked to find HF, which is kind of, it's not part of this triangle, but MF is. Okay, so here's MF, and this is K up here. So we would try to first figure out that this is going to be an isosceles right triangle because of the 45 degrees, and we would then find what the legs are. And so the legs, if you think back to your special right triangles, are always equal to a times root 2. And so this would be dividing by root 2, and you would multiply by root 2 on both the top and the bottom. This is called rationalizing, and that's how we get 8 root 2 over 2, which reduces to 4 root 2. But that's not your final answer. MF is just part of, it's the chord that we know was congruent to BD, but we know that that chord is going to be bisected because there was a theorem that talks about if there's a right angle and this is perpendicular, so I'm sorry, it's perpendicular, then it would also be bisected there. So this would be, if this is 4 root 2, so is HM. So HM, which is equal to MF, is 4 root 2, and then that means if I want the total distance of HF, then that would be 8 root 2. So these do take a little bit of time to kind of work through, and so you won't have, like, of course, many of these for the quiz or the test, but it's good practice for sure. Okay, so the next one deals with the same triangle. It says measure of angle 1 is 60 degrees, so it's again another special right triangle. For the sake of time though, I'm going to actually move on to the next page just so that we do have some time to go through the inscribed angles. I'm going to write down some of the answers on this that you can all, of course, try out, but the main idea on all of these is start with the triangle that is giving the information. So for our next one here, this triangle, the same one, we would just kind of fill in what we know, 60 degrees, right angle, and you know that BD this time is 16. So that chord BD is the same as chord HF, which is also 16. And so once you know that HF is 16, you also would be able to then find MF. That's down here. This one is K. And so we know the measurements. Remember, this is going to be a special right triangle. If you know HF is 16, you would then know that MF is 8. Remember, because it's being bisected. So if I know that this is 8 and this is a special right triangle, I know the short leg because it's across from the 30 degrees. So this would be doubled. So that would be 16. And this would be 8 root 3. But the question wanted us to find AE, which is a diameter. And what I found so far was BF, or KF is a radius. And so if I can just double that 16, that's where I got that 32. Okay, so that was the second one that went over, but again, these take a little bit of time to go through. So for the next two, I'm just going to go ahead and write down the answers. These are also in Canvas, so please check those out. And if you need more help going through these, I can, of course, spend more time on them when I get back. Okay, so these are the answers for these two. For the letter D, you just need Pythagorean theorem, but again, C was another special right triangle. Let's get to the new stuff so that we can try out figure out what are inscribed angles and how we can find their angle measures. So we have some new vocabulary. The first one is, it says an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So this is different from a central angle. That's what we saw last week. Central angles had their vertex on the center. Well, if you notice from this diagram, the center is not even on the diagram here. It's just showing that this point here, letter B, is the vertex and it's sitting on the actual circle itself. And the chords, it's saying the sides of the angle are chords of a circle, which these two, A, B, and BC, are chords. And so what ends up happening is that an arc is created as a result. Here's the arc that is opening up from these two chords, or specifically from this angle ABC. This arc is called arc AC. And so it says the arc that lies on the interior of an inscribed angle and has endpoints on the angle is called an intercepted arc. So the two new words that you should know today are inscribed angle and intercepted arc. So this angle here is called inscribed because it's not a central angle, it's not sitting at the center, and the arc that gets created as a result is called the intercepted arc. And so there's actually a relationship between the two. For these first three diagrams, they're all different diagrams showing you same idea. These are all three different inscribed angles. Now, there's on these three problems, and you can check Canvas if you'd like to, but there's an explanation or a proof for each one of these to help you find what is the conclusion that we're kind of figure out, which is down here, of what is the relationship between an inscribed angle and its intercepted arc. So instead of telling you doing all three of these and showing you the work that goes behind it, what ends up happening on all three of these scenarios is that the measure of angle ABC, and again, if you want the work that goes with it, this is all in Canvas, but I'm not going to walk through it because it gets to be a lot of information. But what ends up happening is that the measure of angle ABC ends up being half of x. Now, x is going to be the intercepted arc, the arc that's kind of opening up to that inscribed angle. So if that's x, this is x. These are the inscribed angles. These are the intercepted arcs. And so in every single one of these different scenarios, you would find out that the intercepted arc would be half as much, so 1/2 of x. And so we'll write this down so that it's more clear, but just so that you could see it, if you wanted to, again, check the reason for why this happens, that's on Canvas. For the sake of just not confusing you too much, especially with me not being in person, I don't want to add more to it. So here's the conclusion. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So what that means is I can always, if I know what the measure of an inscribed angle is, I can cut that in half to figure out my intercepted arc. So if the inscribed angle is 80 degrees, then I can multiply the one arc times 1/2 to get there. So here's the equation. You could say the measure of the inscribed angle, which in this case is angle ABC, is equal to 1/2 times the measure of arc AC, the arc that is related to that inscribed angle. And that's, move this up. This is always going to be true. So this is what you want to, kind of the takeaway of today is, and we'll try out a bunch of the practice on the next page. There's a couple of examples on the next page, and then there's a bunch of practice that was technically for like as a team pair solo. I might kind of pick a few of those to go through, but I will put the answer keys, answer keys are already up for that in Canvas as well. All right, so we're going to practice this over and over again. The main idea, though, again, just make sure you're not confusing the order of like which one is cutting in half or which one are you doubling, because it's saying here that I have to take the intercepted arc, let's say it's 100 degrees. You would cut that in half to get to your inscribed angle. That would be 50 degrees, for example. So just make sure, depending on which information you start with, you are going the correct way. So let's try a couple of these out. It's very repetitive because it's like, again, looking at either you're given the inscribed angle and you're figuring out the arc, or you were given the arc measure and you're trying to find the inscribed angle. So this first one, you see the arc, intercepted arc here is 100 degrees. So we know that the relationship here is that this intercepted arc, we need to cut this in half to get to angle GHJ, which is the inscribed angle here. So this would be 50 degrees. So measure of angle GHJ equals 50 degrees. You don't have to show any kind of work for these. You just have to know the relationship. Okay, and so these go pretty quick. Now this time you know the inscribed angle is 40 degrees and you want to figure out the arc that goes with it, so you double it this time. So it's just 80 degrees. Okay, this one we have a couple more things to figure out. And so it says this time 31 degrees. It helps to outline the angle that you're referring to so that you know which arc you're referring to. Okay, so the arc that's created from this 31 degree angle is arc RS. And so we would take that 31 degrees and we would double it. So the arc should always be larger than the inscribed angle, double exactly. So make sure it has that relationship. Don't flip it around, like don't try to divide 31 by 2. Don't divide it by 2 or take 1/2 of it. So that's 62, but notice also that this same 62 degree arc is opening up to a different inscribed angle. This angle is RTS. And so it's going to have that same relationship, except you're working backwards now. You're saying that this arc, if it's 62 degrees, that it is double the angle here. And so then I would have to divide the 62 degrees in half, and that's how I would find out that that's 31 degrees. So let me write out the two answers. Arc RS is 62 degrees, but measure of angle RTS is 31 degrees. Those are the two answers on this one. Okay, so that's pretty much it for today. It just kind of keeps practicing over and over again. So you can either, well, I have the sub pause the video here and you can try out some of the examples that are coming up on the next 3, there's like a team, a pair, and a solo, and there's a bunch of examples, but there's one diagram that kind of goes with each of them up until the next page. But then you can go on Canvas and kind of check the answer key for some of these if you'd like to, because that would be really helpful. Actually, just real quick before that, the last part here should say, what do we notice? It's that the two inscribed angles of a circle intercept the same arc, then they are congruent. That's what we saw for like what happened here. There was 2 different inscribed angles. They were both opening up to the exact same 62 degree arc, so then 31 degrees for both means they are congruent. Okay, so that was just a kind of just to finish that one up. The rest of these, again, are on Canvas. The main idea for, as you try to do this out, or figure some of these out, is always draw out the inscribed angle so you know what arc it's opening up to, and then you're either just cutting in half or you're multiplying by 2. Now on this first one, actually, we'll go ahead and do one together since this is a team one anyways, and then you can try out the pair and solos. So example 3 tells us that we have 2 diameters here, QS and PR. Name 2 pairs of congruent angles in the figure. So there's angle Q. Here would be congruent to angle P. Would also, and then the other pair could be that R would be congruent to angle S. And here's the reason why. If you notice that these angles that we just mentioned, like angle Q, it's opening up to 81 degrees, well, so is angle P. That's why those would be the congruent ones. And then I could do the same thing, but looking at the angle R, I know it's hard to see because they're overlapped, but now that I do it like this, this arc PQ would be the same for angle S as well. So it's opening up to the exact same arc, which is PQ. Okay, so that's why we know that those are congruent. So to finish these up, and they go pretty quick, you're again just either multiplying by 2 or cutting in half or figuring out what the leftovers are. So SPR is an angle. Talking about this angle here, it's opening up to the intercepted arc, which is SR, which is 81 degrees. You have to cut that in half. So that would be 40.5 degrees. Okay, PTQ is referring to this angle here. So to figure this one out, you're going to look at the fact that this is a central angle, right? This is 81 degrees. We saw this before. This is not an inscribed angle. This is from last week when we talked about central angles. If the arc is 81, then the central angle here is 81. This arc is all, and then these are vertical angles, right? So these angles have to be the same. Then that means the arc measure for PQ is also going to be 81 degrees. So this is 81 degrees. PTS. This time it's this angle here, which is not vertical angles, but these are a linear pair. You can just do 180 minus 81, and you find out that that's 99 degrees right here. Okay, Okay, so both, and then this would be 99 as well, because those are vertical angle again. Oops, I'm sorry, not seeing this well. Okay, and then we have arc PQ. We just figured that out. It is 81 degrees because it was the vertical angles here, and then you have that arc. Measure of arc PS is talking about this one here. Now look carefully at the diameters. We have a semicircle here, so the 81 degrees with PS has to make it to 180, so that would just be 99, or you could have used the central angle that you came up with earlier, that those would have to be the same as well. Okay, and finally, measure of arc SPQ would be 99 plus 81, which is 180 degrees also, because that's another semicircle. Okay, so that's kind of how we work through some of these. Try out the next example 4 and example 5 as like, you can try it with a partner, you can try it on your own, but lots of good examples. On this one, be careful here, because it looks like you don't have the center. There's a letter E here. Actually, I'm sorry. It tells us that the center of the circle is F, not E. So don't think that E is a central angle on that one. F could be anything that has F attached to it, like the 76 degrees. That would be a central angle, but not this one here. So once you figure this out, it is not the same as that arc measure. So try those out. If you do get stumped at all, check the answer key, and then I will go over it too when we get back. All right, have a great day, and try out the 9.7 homework as well.